In the previous video, we explored a simple but unsettling idea. What if reality is a simulation? But one comment pushed this much further. Simulation theory is dead. UBC killed it with the non-algorithmic wall. The future is biological. If that's true, then you are not a rendered entity inside a cosmic computer. You are something far stranger. And if simulation theory collapses, one of the strongest explanations of reality just failed. So today, we're not asking a casual question. We're asking, did scientists just break the simulation hypothesis? First, clarity. The simulation argument, most famously articulated by Bostrom, does not claim we live inside the matrix. It makes a probabilistic claim. If advanced civilizations can simulate conscious minds, and if they run many such simulations, then statistically, simulated observers may outnumber biological ones. Meaning, you could be simulated. But here's the hidden assumption. Physical processes must be computable. Not easy, not efficient, but computable. In other words, there must exist an algorithm capable of reproducing physics. If that assumption fails, the digital simulation collapses. Now enters the non-algorithmic wall. The claim is radical. What if some processes are fundamentally non-computable? Not just complex, not chaotic, impossible to simulate, even in principle. If that's true, a digital simulation becomes impossible. Game over. But here's the critical question. Has this ever been proven? As of now, no such physical process has been confirmed. There are arguments, interpretations, mathematical ideas, but no experimental proof. And there's a difference. We don't know how to simulate this yet, and this cannot be simulated at all. Complex does not mean non-computable. Mystery is not evidence. But the comment didn't stop there. It pivoted. Maybe reality isn't digital. Maybe it's biological, a living substrate. And suddenly, we're not debating code, we're debating life. We now have Xenobots, reconfigurable biological constructs built from frog cells. They demonstrate primitive self-replication. That's real research. We have living bioelectronics, systems combining biology and circuitry. We have quantum biology, suggesting quantum effects may play functional roles in life. This is not science fiction, but here's the key distinction. These discoveries show that biology can process information in astonishing ways. They do not prove non-computability. In many public discussions, the term non-computable is used loosely, often meaning extremely complex. But formal non-computability is a precise mathematical claim, and that claim has not been proven in physics. Let me ask you something uncomfortable. If biology can self-organize and replicate, why assume silicon is superior? We built computers, so we imagine reality as one. That might be projection, but projection is not proof. Here's the deeper problem. The universe is mathematical, clean, precise, elegant. Quantum field theory, gauge symmetries, renormalization, all expressed in equations. If reality were biological at its foundation, why does it look like math? That question matters. Now consider this. What if the debate itself is wrong? Digital versus biological might be the wrong frame. What if reality is substrate agnostic? Something deeper, capable of both computation and life? Then the non-algorithmic wall doesn't kill simulation theory, it evolves it. From universe as a video game to universe as a generative system, self-organizing, emergent, possibly self-replicating. And that's more unsettling. Because if reality reproduces, extinction isn't failure, it's a feature. If reality is biological, what is reproducing? At what scale? Inside what environment? Replication implies boundaries. Boundaries imply environment. Environment implies hierarchy. And hierarchy means we are not at the top. That is a much bigger claim than we live in a computer. That's cosmological biology, and extraordinary claims require extraordinary evidence. Philosophy does not kill physics. Evidence does. So, is simulation theory dead? No. But the purely digital version may be incomplete. And that's not failure. That's evolution. If you know of peer-reviewed research demonstrating a physically non-computable process, drop it below. Not interpretations, not headlines, papers. Let's push this conversation beyond aesthetics into rigor. If you're interested in where physics, computation, and life collide, subscribe, because we're not doing surface-level content. We're exploring the boundaries of reality, and the deeper we go, the stranger it gets. But here's the thing. Everything we discussed today, simulation, non-computability, biological models, hides a deeper question. Not whether we live in a simulation, but whether reality itself is computable at all. Because if computation has limits, real, mathematical limits, then the digital framework is not just incomplete. It may be built on a false assumption. So in the next video, we step away from simulation and go to the source, to Alan Turing, to the halting problem, to the proof that some problems can never be solved by any algorithm. And then we ask the uncomfortable question: is the universe one of those problems? Because if it is, this changes everything. I'll see you in the next one.